Hi, I will walk you through a three-tier application I deployed using AWS. In order to access the application, we use the Elastic Load Balancer. So when I go HTTP slash this and the load balancer DNS name, and here is the application. It is fully available. And it uses the Postgres RDS. So let's say I put in my date of birth. I'm able to access it. So every information or categories of the items here, they're all residents in the RDS database. So now let's go into the architecture. For the architecture, I used a VPC, having all the resource within that private network. And I used three different private subnets to host the RDS. So there is the primary RDS, which reads and writes information into the database. And there are two in two different availability zones, which only read information that is available in the primary RDS. This is created for availability. So if there is an issue in one availability zone, we have the application up and running using the other databases in the other availability zone. As well, I created public subnets which host the EC2 instances and in three different availability zones. Again, this is for high availability. If, for instance, there is an issue with one of the EC2 or there is a increase in the usage of the application, it is able to absorb, or the application is still highly available and scalable because I included also an auto scaling group, which is able to spin up an instance when there is an increase in demand of the application or reduce the EC2 instances when there is low demand. All of these things were specified in the ESG auto scaling group when it was being configured. I would go through the Terraform infrastructure codes that was created. Also, this application is highly available because I used an application load balancer, which you can see here, which is used in accessing the application, as we can see from the URL here. And with this application load balancer, if there is a new EC2 instance that is being spin up, I don't have to worry because, okay, there is a change in the IP address, but the Elastic Load Balancer stays the same. So with this, we are sure that the application is always available. Now I will go into the EC2 instance just to show you what is going on. So this is the primary EC2 instance that I first created. In this EC2 instance, this is where I configured the application. I deployed the application, setting up all the libraries, dependencies, and every other thing that is needed in creating the app, in deploying the application and making it readily available. After creating this in this EC2 instance, I built an AMI from it, which you can see this image. So with this image, that is what I used in my launch template. So I have a launch template here. And in this launch template, you can see that the AMI I showed you is what is being used. And with this, if a new instance is being created by the auto scaling group, it uses this AMI. And with this, I am sure that the application will always be available for the users. Now I will go into the VPC just to show you the setup within the VPC. So the resource map, you can see here that I have six subnets, three private subnets and three public subnets. So you can see that for the public subnet, it has access to the internet gateway for the three of them, and for the private subnet, there is no internet access because it's private. We're keeping it isolated from the internet. And I would also go over this is the internet, the route tables. So we have the route tables for the three subnets, the privates, and also the public. So now I would show you the RDS. We go over the RDS. So in the RDS database, I created the primary, just as I explained before, and I created two replicas so that if there is an outage of one, the other two is able to suffice and ensure that the application stays available for the users. And this is the database stores all these informations regarding the product and all of its all information regarding the products and all. I also included you can see here that in the architecture, there is an S3 bucket, and in the S3 bucket, that is where the avatars are being stored for the application. So, just a moment, please. So I will go over to S3 buckets, and yeah, you see that we have the avatar, and then we have a folder where all the avatars are being stored. Now that we have gone over all the application itself, you can see that I'll go into the repo again, and then you see that this explains the private subnets and the internet gateway, just as I explained to you. I have the Terraform infrastructure. So in this, I have an infrastructure where I created modules for each of the resources that was created, just as I've shown you in the console already. And I use the secret manager in order to keep the credentials for the RDS. This keeps it secured, and I'm sure that the credentials for the RDS is being secured. And networking, we can go over into the itself, some modules we have. So for in my networking data, I have I've created the resource of VPC, Internet Gateway, route table, associated route table, private and public subnet, and also the security groups. So for my security group, I created security group for EC2. That was the primary EC2 where I initially deployed the application and created an AMI image form. Then I have the database as well for the RDS, security group for the RDS, which I opened at port 5432 because I'm using the Postgres database. And then I have that of the application load balancer. So there is a different security group for them and also for the auto scaling group as well. I could show you this in the console as well. We could see that the EC2 security group. And then you see that we have all of this DB, the security group for, okay, this is better, the names, the load balancer, the ASG, the database, and also for the EC2. So with this, I'm sure that I'm sure we could check, for instance, the database, so we could see the inbound routes. For the inbound routes, what was specified is just 54 at port 5432, just as I showed you in the Terraform. And when we go to the all those this, we see that we have it at port 5000 because our application is working at port 5022 for SSH in order to SSH into the EC2 instance as well. And the load balancer we have at port 80 because for the load balancer, it's interfacing with the internet. So we need to open it at port 80. And if we check the listener rule as well, yeah, at yeah, so we can check the listener rule. I will go to load balancer this and listener rule. We'll see that it's open at port 80 as well. All of these things is to showcase that this application is a three-tier architecture model, which has the front end, as we can see. Then we have the just go back to the architecture. Then we have the database with the RDS, and we also have the auto scaling group and the load balancer, which ensures that the application is scalable, is able to adjust with the demand of the use of traffic, and it also has the application load balancer. I hope you enjoyed this walkthrough of this application. I enjoyed working on it because I started small in the sense of trying to deploy it just on an EC2 instance, and whenever I terminate it on the console and on the terminal, the application isn't running. But right now, even now that the application is not running locally on my computer, the application is readily available. That's thanks to the Elastic Load Balancer, the auto scaling group. And if, for instance, for any reason, I have this not running again, it's immediately a new instance is immediately created to suffice or ensuring that the application is always available. So we'll see that in a moment. Okay, it's taking some time, should stop, but a new instance will be created. So this is a brief walkthrough on the application and also the all the resources we are created via Terraform. Verify Terraform. So if for any reason I destroy each of the resources, I can easily spin up it and make them available again based on the Terraform infrastructure that I have created. Let's see now if this is, yeah. So we see now that we have a new grocery app created. So it's initializing and that's thanks to our auto scaling group that we have here. That is the goodness of an auto scaling group. And see that the capacity is one but it can go to a maximum of 4 instances created when there is an increase in demand. And it uses our launch templates and also the AMI ID that I've created with an instance T3 micro and it uses our keep here. You don't have to worry about those informations I'm giving out the ARN and everything because at the end of this, I would destroy all of these resources. Thank you very much. I hope you enjoyed this walkthrough as much as I did working on this application. Thank you and have a good one.